All right, let's dive in. We all know the weather is getting more extreme, right? Well, it turns out it's not just about the air or the oceans. A really fascinating new study shows it's actually changing the stability of the very ground we stand on.
So that leads to a pretty big question, doesn't it? Is all this wild weather making the ground, well, less stable? I mean, we feel the heat waves, we see the floods on the news, but what's happening underneath it all, to the rock and the soil? Is there some hidden connection here that could put us all at greater risk? That's what we're going to unpack. And listen, this is not just some what-if scenario. It's already happening. Take a look at this. Back in October 2021, this became a tragic reality. Record-breaking rain just hammered China's Shanxi province for days on end. And the result? It was absolutely catastrophic. We're talking widespread landslides that buried homes, forced thousands to flee, and even wiped out priceless ancient buildings.
Yeah, so the thing about that tragedy in Shanxi is it wasn't just a one-off. It's a really stark example of this dangerous global pattern. The bottom line is, as our weather gets wilder, the ground itself is becoming more and more unstable. So this has basically kicked off a huge scientific detective story. Researchers know there's a link here, but the million-dollar question is how? How exactly does a blistering heat wave or a sudden crazy downpour actually get a hillside ready to just let go? That's the mystery they're racing to solve.
Okay, so to crack this case, scientists went right to the source. You could even call it the crime scene, Shanxi province. It literally became the perfect real-world laboratory for digging into this link between climate and catastrophe.
So you might be asking, why there? Why Shanxi province? Well, it's kind of the perfect storm of conditions. You've got this really unique geography, mountains, hills, plains, the whole shebang. It has a climate that's already known for being extreme, and sadly, it also has a long history of these kinds of geological disasters. All that together makes it the ideal place to hunt for those hidden signals that connect the weather to landslides.
And get this scale of this investigation is just wow. I mean, the researchers didn't just look at a few isolated incidents, no way. They mapped and analyzed the precise locations of over 11,000 geological disaster sites. Just think about that. That is a massive amount of data to work with.
And once they had all that data, they found their first huge clue. It turns out these disasters weren't happening randomly at all. They were actually clustered in these very specific hotspots, mostly along the province's central spine. And that right there was a clear signal that there was something bigger, something systematic going on. All right, so finding where the disasters happened, that was step one. But the next, and honestly the most crucial part, was figuring out why. It was time to connect the dots between the climate data and that disaster map.
So how do they do that? Well, scientists use this tool called a climate index. The easiest way to think about it is like a specific fingerprint for a weather event. So instead of just saying, man, it was hot, an index gives you something really precise, like the number of summer days over 25 degrees Celsius, or the maximum rainfall over a 5-day stretch. See? Super specific.
Okay, so here's the game plan for their investigation, broken down. Step one, they gathered a mind-boggling 46 years of daily weather data from all these different monitoring stations. Step two, they took those 11,000 plus disaster sites we talked about and plotted them on a map. And step three, this is the cool part, they fed all of that information into super powerful computer models to hunt for any hidden connections between 32 different climate indices and the disaster locations.
And the initial results? Well, they pretty much confirmed what a lot of people already suspected. Over that nearly half-century of data, the trend was totally clear. Shanxi is getting hotter, for sure, and those really intense extreme downpours, they're definitely on the rise. But, and this is where the story gets really interesting, when the computer models started digging deeper, they didn't just find the obvious stuff. Nope. They actually uncovered some really surprising, almost counterintuitive culprits behind these disasters.
So let's start with temperature. The extreme heat part, that kind of makes sense, right? You get more intensely hot days and the risk of disaster goes up. No huge shocker there. But here's the twist. An increase in cold spells was actually linked to a reduction in disaster hotspots. So right away, that's a clue that this whole thing is way more complex than just hot is bad.
And that complexity, it just explodes when you start looking at rain. The simple assumption would be more rain means more landslides, right? But what the researchers found was, oh man, it's way more complicated than that. It turns out not all rainfall is created equal.
And this next part, this is really the aha moment of the whole study. Just look at this paradox. On one side, you have sustained rainfall over time.
You'd think that's bad, but it was actually associated with a decrease in disasters, probably because it helps keep the soil stable and healthy. But then on the other side, you have these short, intense, extreme downpours. They just totally overwhelm the ground's ability to soak up water, and that dramatically increases the disaster risk. So the key takeaway is incredible. It's not about how much it rains, it's all about how it rains.
Okay, so understanding what causes these things is huge. But the real game changer, right, is using that knowledge to predict and maybe even prevent future disasters. So, the big question now is, how can this new insight help us forecast what's just around the corner?
Well, the research team took all those key climate factors they'd found, the type of rain, the extreme heat, and used them to build predictive computer models. They basically had a bake-off, testing a bunch of different kinds of models against each other to see which one was the absolute best at predicting where these disaster hotspots would pop up.
And when the results came in, there was a clear, decisive winner. A model called Random Forest just blew the others out of the water. I mean, look at this. Its prediction accuracy was nearly 3 times higher than its competitors. It was by far the best tool for the job.
So you're probably wondering, what the heck is a random forest model? Well, here's a great way to think about it. It's kind of like using the wisdom of the crowd. Instead of relying on one single expert to make a call, the model creates thousands of them, these little decision trees. Each tree gets a vote, making its own little prediction. Then the model just combines all those votes to make one super accurate final prediction. Pretty clever, right?
And this is the part that really matters to all of us, no matter where we live. Because this study isn't just about one province in China. It's a blueprint. It's a proven method that could be used to create early warning systems for these kinds of disasters anywhere in the world that's facing these extreme weather threats.
And all of this leaves us with one last really big question to think about. This science is essentially giving us a brand new crystal ball, right? One that makes it easier to see where these climate-fueled disasters are going to strike next. So, if we can see them coming with more and more accuracy, what's our responsibility to actually do something about it? That's a question we all need to be thinking about. Thanks for tuning in.